All right, so we've got color, size, some movement going on, but right now we have a kind of somewhat slightly static and predictable movement going on. And one way to overcome that is using the new noise module. And so we are going to turn on noise, and immediately you can see, whoa, we get a much more complex, chaotic movement pattern. I really love this new, the new noise tools. I just think they're so cool. There's so much that you can do with them. One great way to look at them is if you just pull up the dust mote system and just play with the noise effects. You can really see a lot there. I might try to stick that on at the end. I actually wanted to do it in the training before, but I ran out of time, so I had to cut it because this one also uses noise. But anyway, it's really cool. So what we're going to do is we're going to pop this open. And so let's just cover the basic settings first, and then we'll look at some of the more advanced stuff that we're actually going to do here. So the strength is just how much movement is applied to the particles from the noise module. So if we turn this down, you can see we can get a much, right? If we take it almost down to 0, we're getting almost no noise. We start to turn it up. We're getting sort of more increasingly sort of violent movement. And obviously, if we go all the way back up to 1, we get this kind of crazy, complex swirling, which, really looks really nice. The frequency is, we can actually see, so the noise module gives us this nice graphic that represents the graph of the noise. Now, it's worth noting that the noise graph is actually a 3D noise graph, right? We can choose how many dimensions are being generated here. We can have one-dimensional noise, right, which is literally just a set of values along the x-axis. Two-dimensional noise, which looks, the preview is going to look the same because we have now noise along the x and y axes, or three-dimensional noise, which actually includes noise along the z-axis, which is being rendered in 2D here. So pretty interesting. It's worth noting that each of these is a different degree of, requires a different degree of computational resources, right? So if you can get away with the low noise, like if you could do this, I don't think it looks great for our fire effect, right? If you could, though, this would be computationally cheaper, right? I'm not sure whether this is run on the GPU or the CPU. That would be something I would like to find out, actually. I would hope GPU, but you never know. But so we're going to stay on this high 3D noise because it's giving us a nice effect. And what we're going to do is we are going to actually apply. So just to go back to frequency, right? The frequency, you can see how it changes the graph. Let's actually go to let's go to like a really stark graph. So you can see here, right? On a low frequency, we just have these kind of big stripes of change in value. And you can see we're getting these kind of erratic, almost on-off changes to the noise, right? As we increase the frequency, we get this more chaotic movement because the values are changing more often, right? If we go up, we get this crazy, let's go way up, we get this crazy kind of jittery, almost sort of like insect-like movement. Lots of interesting creative possibilities here, right? But what we're going to do is we're going to stick with a frequency value of 0.5, and we are going to separate the axes for the strength. So we're going to turn on separate axes, and we're going, instead of using constants, we're going to use curves. And I'm going to actually make my inspector a little bigger so we can see that better. And so the first value that we're going to want along the x is going, and I'm going to turn off these guys. Here you can see, right? We might want to be editing these together, so we would want to visualize them together, but I don't want to see them right now, so I'm going to turn them off so I don't get confused with my simple, tiny mind. And what we're going to do is we're going to have this going from 0. And of course, you can, if you, so here I want to go from 0 to around 0.5 on this graph. So what I'm going to do is click on the x-axis here and scale the whole editor. So it's taking me from 0 to 0.5 just to make that easier. And then I'm going to double click to add a point here, drag it up, and I'm going to go for a curve kind of like this along the x. And basically the exact same thing along the y. So I'm actually just going to copy and paste that. And then on the z-axis, we're just going to leave it at default because we don't actually want it to move along the z-axis. Let's pull it up. So now we can see getting this really nice pulsing interesting flame system, which is starting to take on the character that we want. Now, just to go over the other parameters of the noise, you can also layer multiple octaves of noise, right? And so what this means is, and with a corresponding increase in processing cost, right? So if we raise the number of octaves, the octave multiplier is the strength at which this is overlaid over the noise graph. So you can see now we have this more complex pattern because we have a second octave of noise being overlaid. Now, to what degree, let's set this to 0, you can see it's making a difference in the movement of the system. Let's take it back up to 0.5. There is a real change in the amount of complexity there. Exactly what is going on, I could not tell you, besides the fact that we just have a more complex graph that we're pulling data from. We're actually going to, just keeping in mind, right, that there is a performance cost with that. And then you can scale the octaves as well. The octave scaling, I'm going to read from the documentation. So I'll read all 3 entries actually because it's worth just getting it down correctly. Octaves specify how many layers of overlapping noise are combined to produce the final noise values. Using more layers gives richer, more interesting noise, but significantly adds to the performance cost. The octave multiplier for each additional noise layer reduce the strength by this proportion. And then for the octave scale, for each additional noise layer, adjust the frequency by this multiplier. So, you know, I would say a lot of this stuff is very much seasoned to taste. I don't think you're going to be doing sort of like, I don't think you're going to be doing super mathematically precise simulations of noise patterns with this. Maybe you are. I don't know. I don't know you. But I would say you can kind of have a play around with these and come up with something that has the right feeling. I'm going to go back to 1 octave of noise. Now, the other thing that we have, which is an interesting option, is the scroll speed. So right now we have a static noise pattern, but if we start to turn up the scroll speed, let's set it to 0.2, we can see that our noise graph starts scrolling and changing. And again, we get an interesting further change in the, let's zoom out a little bit, in the movement behavior of our particle system. So we're really getting something that's starting to have quite a bit of visual sort of and movement interest on its own, just with these kind of primitive dot shapes. The next, and really primarily for me, the interest of this is coming from the noise module, right? So I strongly encourage you guys to play around with this. Now, let's add in the final stage, which is that we're going to add the textures. So the way that you add textures is in the renderer. Right now, we're rendering the default particle using the default particle material, right? So we need from the fire explosion effect category, the materials, and we need this flame round yellow particle material. So I'm just going to grab that and drag it in. And now we get this kind of interesting abstract effect. And so what's happening here is we have our texture sheet being rendered as a single image. So if you've done 2D in Unity, or especially 2D animation, right, you may be familiar with the idea of sprite sheets with multiple frames of an animation. That's exactly what we're doing here, except it's a texture. And so what we're going to do is we're going to, there's one little adjustment we need to make here to the pivot. We're going to set the pivot at -0.15. I just assume this is some detail of the way that the artist made it. I'm just going to copy that. I don't know why specifically he made that decision. And we're going to turn on texture sheet animation, right? So texture sheet animation is what's going to allow this to treat this as multiple frames instead of a single frame with lots of individual elements in it. So what we're going to do, if we look, let's just look quickly at the texture sheet itself. This is what it looks like, right? We can see it in miniature, but here it is. We've got alpha and then all the different frames of all the little sort of flame particles. And what we're going to do is we are going to say, okay, and the important detail of that was, right, that we have 5 on the y-axis and 10 on the x-axis, right? So we're going to set that in the texture sheet animation. So we're going to say we have 10 tiles here and 5 tiles here. And now it's treating each of those as a separate frame. And we have something that looks quite a lot like fire. And that's actually the only thing that we need to change in here. I'll just briefly mention, we could use a single row if we wanted to instead of the whole sheet. We could have the frames, for example, evaluate backwards if we wanted to. We got a sort of backwards fire effect. It's kind of cool. Definitely if you were doing some like weird magic spell effect, that might be interesting. I'm going to switch it back to forwards, right? Because this is just saying go from frame 1 up to frame 10 or up to whatever it is, 50. Evaluate the whole sheet over this amount of time with this curve. The start frame is going to be 0. The number of cycles is 1. We can flip the U or the V, choose the UV channels. None of that we need to change. And that is basically all that we need to do. Let's see, am I missing anything else? I think that's basically got it, right? I feel like I'm missing one thing because it's going into these moments of really spreading out a lot. It's a lot of little things to copy here. I might have missed a step. That's okay. I'll look back over it in a minute. You can see the basic effect is there. Okay, so let's pause there. And next, we're going to move on to creating the embers and the light effect. And let me just look at the chat before I do that. Oh, should it be 0? Yeah, let's see. Let's try it on 0. That looks better, right? There we go. Yeah. Yep, that was it. See, that's what I get for trusting Twitch chat. Just kidding. All right, there we go. So yeah, so we just want to make sure that our the Z. It's funny because it doesn't look. What is it? Oh, this is because this is inspector is. This is the thing that threw me off, just so you can see. Here, it looks like the Z is at the top, right? But in this graph, the top is set to 0. So it's just a little weird looking. That's all right. I should have just copied the graph. When in doubt, just copy and paste, right? Okay. Somebody's asking for tips for particle systems on mobile. Well, I would just say general tips for particle systems are that particle systems are an efficient way to render lots of similar visual elements, right? So if you have, here's an example, right? Let's say you're doing a mobile Sonic style game, right? Or you're doing Sonic because you don't have the rights from Sega, right? So Sonic gets hit and he sends rings flying out, right? Now you could go and spawn 20 different ring objects with rigid bodies and colliders, which would have a bunch of cost associated with it. Or you could use a particle system and 2D particles that have collision on them so they bounce around and register collision events so that they could be picked up or whatever. That would be a more efficient way to do it than to instantiate 20 new objects. But the real answer to any performance question is your mileage may vary and you should test and profile on your device. But generally speaking, particles are more efficient than spawning lots of game objects, right? I know, for example, the game Assault Android Cactus, which is made with Unity, and it's kind of a top-down shooter, sort of bullet hell, twin-stick shooter action game with tons and tons of bullets on screen at any given time. In that game, they used particles to render all the bullets, right? Or to model all the bullets. And I think saw some performance increase by doing that. So that's an example of a performance gain from using particles instead of lots of game objects, for example. Yeah, somebody's saying they did not know particles could register collision events. Yep, they can. You can use them and you can send messages to scripts to say something was hit by a particle and take damage and stuff. You can do a lot of interesting stuff with it, or just have them bounce around visually. I'll show a little example of that when we get to the next system. Yeah, obviously we are going to go a little bit over time. I think it's worth it, but just a heads up, right? We're already 50 minutes in, and I've just gotten through basically the first one. So just hang on to your hats, folks, because we're going to go a little long. But I think it's good content and it's worth it. The next systems are not as complex, and I'm going to start going a little bit faster as we go.